We're going to be talking about regression today. So here's the big goal of this lesson. Basically, we want to set up a conceptual understanding of regression before we actually learn to calculate and find it. So today we're going to do just a brief review of linear equations. Then we're going to talk about the regression as the center line. Instead of a center point, like the mean, we're going to talk about a center line. And then we're going to talk about prediction and error. All right. First, linear equations. So y equals mx plus b should be pretty familiar to a lot of you. Whenever we think of y equals mx plus b, y is sort of, you could think of this as the output, or f of x. X will be the sort of input, or often, you know, whatever's on this horizontal axis, the x-axis. Now, b, we'll start with b, is the y-intercept. Another way you could think of the y-intercept is where x equals 0, what is b? Because x will be, you know, here, right? And so anything where x is 0, that will mean that y will have to be somewhere on this y-axis, right? So that's what we mean by y-intercept. And then m is slope. And, you know, slope, I think, is something pretty, everybody pretty much remembers. But just in case you don't, here's how we calculate slope. I'll put it down here. Slope is really the change of y over the change of x. So when we say change, we think of delta, right? The change of y over change of x. But a more common way people refer to it is rise over run. And when you think of rise, you think of going up vertically or down vertically, so the anti-rise, and then running is sort of more horizontal, right? So what is the rise over run? And that's what we think of as slope. And when we talk about rise over run, we really mean in the direction sort of to the positive direction is up and right, and the negative direction will be down or to the left. So you could think of rise over run as an indication of rate of change, how much x changes in relation to y, or vice versa. And so these are sort of the components of our linear equations. And every line, it doesn't matter what kind of, it doesn't matter, you know, what the line looks like. Every line, every straight line has an equation, and from that equation you could figure out where at any x what the y is, at any y what the x is. If you have x, y, and the slope, you could figure out the intercept. If you have the intercept x and y, you could figure out the slope, right? So this is a really useful equation for us. Now, we're going to be trying to find a line that is the mean, that is the center of a bunch of data points. And in order to do that, we would have to find its equation, because the equation is sort of like the name for the line. But in statistics, we're going to use this exact same equation, but we're going to write it in a little bit different way. It's just convention. Nothing conceptual will change, but we're going to change it around just very, very slightly and superficially. The first thing we do is we talk about the y-intercept first. So in statistics, it's y equals b comes first. And it's the first b, so it's b sub 0, or b naught. And so instead of the y-intercept being added second, we start from the y-intercept. And then we add the slope times x. And notice that the slope, it's not called m anymore, it's called b sub 1. And so we have b sub 0, which is the y-intercept, same idea, and b sub 1, which is slope. Same idea as before, right? And so this is how we'll refer to things when we talk about the equation for the regression line. All right. So what do we mean by the center line? Well, if you think about a scatter of data, if you have a whole bunch of data, you want to think about a line that somehow like sort of cuts through the middle of all of these points, right? And so right now we could just roughly draw a line, right? And sort of try to make it cut through the center of all these points, right? But that's a very, very rough line. But in order to find what the equation of this line is, I can, as long as I just have two of the points on this line. For example, if I take this data point and this data point, I could find the equation of that line. Now, it's because by having two x's and two y's, a set of x and y and another set of x and y, I could calculate rise over run, and then from having slope and an x and y, I could calculate the y-intercept. Now, that's a really rough line, but because it just depends on which 2 points I pick. If I pick these 2 points, I'll get this line. But let's say I pick this point and this point. Then I would get an entirely different sort of line, right? And even more, moreover, if I pick this line and this line, this point and that point, I'll get an even more different line, right? And so the question is, which 2 points do you pick, right? It might not be good enough for us to just eyeball things because we're really not sure which 2 points to pick. Now, if you only had 2 data points, then life is easy, right? Like you could just use those 2. But usually we have more than 2 data points. So just eyeballing a rough line may not be good enough for us. But if push comes to shove and we only have 2 data points, we could manually find slope and intercept and find the equation of that line. All right, so let's talk about this regression as a center line instead of a center point. So here are some reasons for summarizing with a regression line. And notice that for all of these, I'm talking about scatter plots. So regression lines are really used for scatter plots. Here, what we want to do is we want to have some variable here. So here's my first variable, variable 1. And here's my second variable, variable 2. And we'd like to get a line that sort of describes the center of all of these points, all these cases, whatever the cases may be. Why would we want a line, right? Why not just a mean, right? Well, sometimes there's not enough info from just a point. If you just had a point, for instance, let's say this point is the mean of my x's and the mean of my y's, right? So that would be x bar, that's the mean of x's, and y bar, right? So let's say that's my center point. That point might not give us enough information about this whole distribution, right? Remember, we talked about how to summarize a distribution, and we want that trend. We don't just want a point. We would like a trend. And when there's not enough information from a point, it's useful to have a center line. Also, we want to find a summary that describes the relationship between the 2 variables. So it's not just enough to have a point. The point won't describe the relationship between the 2, but a line does. A line will tell you whether it's pointing, whether its slope is negative or positive. The line will tell you that kind of information that you would want from something like a trend. And so that relationship is actually really important to us, and we wouldn't get that information from just a point. The third reason that you would want to summarize with a regression line is that it's often helpful to use one variable to predict the other variable, right? And often, by convention, we would put whatever we feel is the predictor variable on the x-axis. So we may use this to predict this. So we may use someone's weight to predict their height, right? Or vice versa, right? In case of weight and height, it doesn't really matter which is the predictor. And really, predictor variables are by convention. They're not causal variables. They are just variables that that we use in order to predict a second variable. And that second variable is called the response variable. And so one thing that's important to know is that the predictor variable, by convention, by just tradition, goes on the x-axis. And the response variable is often portrayed on the y-axis. And so that sort of goes along with this idea of functions, right? That we put in x, and f of x, the function, will crunch out for us an output, right? And that's how we think of predictors. You put in the predictor, and it'll crunch out for you the response, right? A predicted response. Now, when we talk about predictions, those predictions lie on the regression line. So this regression line equals all of our predictions. Right? And so this means that, when we think x is, let's say 27, then the prediction line shows us that y would be 180 or something like that, right? And so all the predictions lie on the actual line. Now, notice that a lot of our points do not lie on the prediction line. And so there's a little bit of difference between the actual data and the predicted data. Now, here's the goal of regression, the goal of this line. Our wish and fundamental desire is to find this line that's the center. It describes sort of the middle of all these points, right? And if you want to think about what the center really means, it's really that all the distances on one side are balanced by all the distances on that side. It doesn't mean that it has to be a perfectly symmetrical distribution, right? It just means that the point in the middle has to be sort of equidistant to all of these lines and equidistant to all of these lines, right? Think about it as like a balance, right? It just has to balance each other out. All the distances have to balance each other out. So that's how I want you to think of it. Distances on one side of the line, right? Balance out all the distances on the other side of the line. So to show you here, here is one distance. Let's take this point. This is the distance, this is my y distance away from the line, right? And I need all of these distances to be balanced out by all of these distances. Right? And so that's the hope of this regression line. And here's a really long distance right here. Right? And so I need all of these distances to balance each other out. Now, how would you find such a line? Because that seems like a lot of work. We have to find a line and then find all the distances and then jiggle the line around and make sure all the distances are really perfectly evenly matched, right? That seems sort of hard. We'll actually learn to calculate the precise slope and intercept of this middle line, the regression line, by using the method of least squares. And that's going to be a beautiful shortcut for us so that we could actually find that line without having to do all that work. That's in the next lesson, though.